The ice tables continue. If you take hydrogen chloride gas and just let it sit for a while, occasionally an HCl will break and another HCl will break, and that'll give you enough material to make a hydrogen molecule and a chlorine molecule. So our ratios for these things are 2 to 1 to 1. And let's keep track of all the stuff they're about to tell us. They put some HCl in a flask. We don't know how much. Do I want to put an X there? I guess, yeah. I think I start with an X there. I might change my mind about that, but let's start with it there. So they say they put HCl in the flask. They don't mention putting anything else in the flask, so we'll say we start with no hydrogen and no chlorine. Time passes, and at equilibrium, the flask ends up with 0.6 moles of chlorine, 1 liter flask, so we don't have to divide any of these things in a weird way. We get 0.600 for our chlorine. Now, what else can we fill in here? If the chlorine went from 0 to 0.6, that means it increased by 0.6. Chlorine and hydrogen are 1 to 1, so this also went up by 0.6. And this being twice as big, being 2 to 1 ratio with the others, means its change has to be twice as big also. So this will be minus 1.2. And filling in the equilibrium arrow, 0 plus 0.6 is 0.6, not surprisingly. And x minus 1.2, not sure what that is, but we can at least write x minus 1.2. So there's our table all filled in. And they told us the equilibrium constant up here. 2 times 10 to the minus 2 is 0.02, so that's information we can use. What do we get if we write an equilibrium law for this? Our products are hydrogen and chlorine. Our reactant is hydrogen chloride, x minus 1.2, and coefficient of 2, so we have to square that. And that all has to come out to 0.02, our equilibrium constant. If we want to rewrite this, because we have 0.6 twice, I'm going to mash those together and just say 0.6 squared. And I'm doing that because the next move I'm thinking of is square root both sides. The square root both sides thing only makes sense if you have even powers for both of these, because it'll strip both of them off. But that does happen with a lot of our questions, so it is a good move to know. If we root both sides of this, like so, that square will get stripped off, so will this. And for our next line, we can just have 0.6, I'm going to lose those extra zeros, over x minus 1.2 equals, and the square root of 0.02 is 0.14142. That's probably enough. Okay, you remember what we do now when we want to get our x out of the denominator? There are a couple ways to do this, and you might even like the other ways better, but the way I've been doing these, you just multiply both sides by the denominator. And over here, the x minus 1.2's cancel, and we get 0.6 equals, over here, this number distributes through the brackets. So we're going to get 0.14142x, 14142x minus, and then we get 0.14142 times 1.2, which is 0.169704. This is just a number. This is a term in x, and this is just a number. So I want to get my x's alone on one side, like on the right where they are now, And I'll get all my numbers over to the left side. So I'm going to add 0.1697004 to each side. These cancel. 0.6 plus 0.1697004 is 0.7697004 equals 0.14142x. Divide by 0.14142, and this whole yucky mess finally goes away. 0.14142. I get x equals 5.44268. So you could put that number here to get the equilibrium amount of HCl, but what they were asking for is how much HCl was there in the flask, and that number is actually X. So our answer should be 5.44268 moles per liter. Significant digit check. K has 3 digits. All of these have 3 digits. So I think I can give 3 digits in my answer. And so 5.44 would be our rounded answer, 5.44 moles per liter. Or if you take how much HCl was there to be the number of moles, then the number of moles equals this concentration times the volume, which is 1. So if you want to answer it that way, you just say 5.44 moles and it's not a concentration anymore. Good? Messy but good? The math doesn't get any worse than this, but, and I know this is a bit of a slog, but we can ask you to do this, so you need to peak to the point where you can do this and get the unit exams done, and then you can forget about it if you want to.